In this video, we're going to talk about factoring sums and differences of cubes. And since factoring is just the opposite of multiplying, we are always going to start with a multiplication problem. So let's start by multiplying these two terms together. It's a binomial times a trinomial. So we're going to distribute we're going to get x times x squared is x cubed. X times negative 2x is negative 2x squared. X times 4 is 4x. If we distribute the 2 through the parentheses, we get plus 2x squared. 2 times negative 2x is a negative 4x, and 2 times 4 is a positive 8. Notice what just happened there. All these middle terms are going to cancel out. The negative 2x squared and the positive 2x squared cancel, and the positive 4x and the negative 4x cancel, just leaving us with x cubed plus 8. So what we have here is a perfect cube. X is cubed, and we have a perfect cube here as well. 8 is just 2 cubed. So somebody noticed that if we ended up with a sum of 2 cubes, that we could factor them just like that. And here's the formula. If you have a perfect sum of 2 cubes, we'll say we have a cubed and b cubed added together. Now a can be anything and b can be anything, just as long as they're perfect cubes in the sum of cubes side of the equation. If we have this situation, we can factor it into an a plus b times the whole quantity. Take the a, whatever it is, and square it. Subtract a times and add b squared. Now that's the formula for factoring a sum of cubes. Let's talk about how to use it with an example. In this example, we want to factor 8m cubed plus 27. And we notice that we have two terms, and both of these terms are perfect cubes, and they're added together. So we're going to use this sum of cubes formula up here. Now, what is that the perfect cube of? Well, we can rewrite that as 2m, the whole thing cubed. And 27 we could write as 3 cubed. So in this example, 2m represents a. That's what's cubed on the left side. And 3 is going to represent b. Now how can we actually do the factoring? Well, all we have to do is follow the formula. We want to write down a plus b. So what was a? A was 2m plus b was 3. Okay? Well, now we want a squared, 2m squared, minus a times b. I'll just write it out as 2m times 3 plus b squared. B squared obviously is 9, but I'll just write it as 3 squared. Now what we can do is simplify the right-hand side. 2m plus 3. 2m, the whole quantity, squared is 4m squared, minus 2m times 3 is 6m, plus, as we said before, 9. Now, we started with 8m cubed plus 27, and we factored that into two pieces, a binomial and a trinomial. What we just did there was an example of a sum of cubes factoring. Sometimes we have a difference of cubes, so we should talk about that. Now, if we happen to have a difference of cubes, it'll look like this. Something cubed minus something else cubed. And if we want to factor that, it looks like this. A minus b times a squared plus ab plus b squared. Now, it looks really similar to the sum of cubes formula. The only difference is a couple of these signs. That plus changes to a minus, and that minus there changes to a plus. Everything else is the same. This is a difference of cubes. Let's look at an example. Let's say we have 2y cubed minus 54z cubed. Now you'll notice there are two terms here. And I see these cubes on here, so I'm thinking maybe this is a difference because they're subtracted of cubes. The problem is 2 is not a perfect cube, and 54 is not a perfect cube either. But if we do our first step in any factoring problem, we take out what we can. We notice that we can factor 2 out of each one of those two terms, so we can rewrite this. We can pull a 2 out of the parentheses, and what we have left inside the parentheses, both terms are actually perfect cubes. Now we can focus on what's in the parentheses and just leave this 2 outside on every single step. Okay, let's do it the way we did the last problem. Here we have something that's cubed, and obviously that something is y. We have a difference, you'll notice, there's a subtraction here. And what's the perfect cube here? Well, that is 3z, the whole thing cubed. So in this problem, a is going to be y, and b is going to be 3z. And don't forget to leave your 2 out in front. We're just going to forget about it, but we're going to leave it there in every single step. And now all we have to do is go to this formula above and copy down the a's and the b's. So a in our problem is going to be y minus, b is 3z, a squared is just going to be y squared, a times b is going to be y times 3z, I'll just write it like that, and b squared is going to be 3z squared. Now for our last step, all we have to do is simplify. We have 2 y minus 3z y squared plus 3yz plus 3 squared is 9, z squared. Okay, we'll keep this video simple. That'll be it for sums and differences of cubes. Basically, all you have to do is know how to recognize the sum of cubes and the difference of cubes, and know how to use these formulas. Okay, for your video quiz, just factor those two things right there.